Alright, picking back up, number 12 is an angle of depression problem. So let's kind of see if we can draw this up a little bit. You don't have to be fancy. I'm going to say there's my airplane, here's the ground, and over here's the airport. So I'm going to make a triangle with these 3 points that I've made here. That's right. So it says from the ground to the plane is 2 miles. From where the ground is over to the airport, that's 5 miles. So I asked us to find the angle of depression. Well, if I'm thinking about this, imagine the plane continuing to fly. If I'm thinking about the angle of depression, it's right here. Well, that's not inside my triangle. But if I remember something very, very old, if I were to extend this and imagine that the ground is flat also, this angle and this one are alternate interior angles. So what I could do is say, well, those angles are the same, so I can just use that for my reference angle. So again, I got from this point to this one by knowing alternate interior angles, something very, very old. Okay? So I'm going to use trig to let me find that angle. So if that's going to be my reference angle, here's my opposite side, here's my adjacent side, and here's my hypotenuse. So looking at this, I'm going to say, well, tangent of, I'm just going to use theta because we don't know it, equal to my opposite side is 2, over my adjacent side is 5. So theta is equal to inverse tangent of 2/5. If you punch that in your calculator, you're going to get an answer rounding it off to my angle of depression is about 21.8 degrees. Looking at number 13, find the missing side in the following triangle. Well, I don't have enough to do Pythagorean theorem, so I'm going to try trig. Again, if that's going to be my reference angle, then there's the opposite side, here's the adjacent side, and here's the hypotenuse. So I know something about the adjacent, I'm going to find out hypotenuse. So cosine is going to be the one I need to use. It pulls in both adjacent and hypotenuse, so I'm going to say cosine of 57 is equal to 13 over x. I'm going to put this over 1 because I can. It's a number. It's a weird looking number, but it's a number. And now I have a proportion. I'm going to cross multiply at this point. So I've got x times cosine of 57 equal to 1 times 13 is 13. Divide both sides by cosine 57 degrees because I want to get x by itself. That's gone. And x is going to be, if you punch all this in right here, about 23.9. The next one. Number 14, find the missing angle in the following triangle indicated by the question mark. So if that's going to be my reference angle, again, I can't say 180 minus 90 minus, I don't know. It's too much missing. So I'm going to have to try, yet again, inverse trig in this problem. That's my reference angle. Here's my opposite side, adjacent side, and my hypotenuse. I know about opposite and adjacent, so I'm going to pull in that trig that uses opposite and adjacent. That's tangent. So tangent of, I'm going to use theta again, is equal to 36 over 46. Sorry. It's kind of hard to see. 36 over 46. Well, theta is going to be equal to inverse tangent, 36 over 46. You punch that in, you've got theta rounding it off to about 38 degrees. Next. Right here, 15 and 16 are non-right triangles. So it's any ordinary kind of triangle. I don't know what kind exactly. Maybe a cute, this one looks like it may be an obtuse triangle. So looking at it, this particular problem with 15, I got 2 options we've discussed. I believe the law of cosine is going to be the way to go. So I want to find AB, this side. So doing that, I'm just going to put a lowercase c there. Doing law of cosine, here we go. So doing this out, I want to put, remember this side and this angle are very, very closely related to one another. So I'm going to put the side that I want to know, and we'll square it. Equal to the other two sides that I know something about, and we'll square those. From here, it looks very, very similar to Pythagorean theorem. But now I throw in a little bit of extra. Minus 2 times 13 times 29 cosine of, and remember the angle that goes here is the angle that's across from that side. So that's going to be cosine of 41 degrees. From here, I don't want to know what c squared is. I want to know what c is. So I'm going to take the square root of both sides. So I've got c being about, and at this point, I'm going to punch all that in. If you plug all that correctly into your calculator, and I'll show you how to do it, you're going to do Control X squared, then you're going to do 13, hit your squared button, plus 29 squared minus 2 times 13 times 29. Then I'm going to hit trig, do cosine of 41, and hit enter. And I get that it's about, if I round on up, I get that C is about 21. And again, I'm looking for a side, so I don't need that degree symbol. Looking down here, I think law of cosine is going to be a good way to go. I'm sorry, law of sine is going to be a good way to go. Because I have two angles. In the previous problem, I only had one. Wasn't enough. So looking at this one, looks like an acute triangle to me. I want to know, again, AB. I'm going to use lowercase c. Why not? So from here, I'm going to say, and remember, law of sine, you're looking at an angle and the side opposite it, and you're creating a ratio of these two numbers. So I'm going to say, well, sine of b, I know something about. Across from that, we'll say it's lowercase b, equal to sine c, and then finally, the side I want to know something about. So sine b, I'm going to fill that in with 44 degrees, over sine b is 7, equal to sine c, I'm going to fill that in with 53 degrees, over sine c we don't know. Now I have a proportion. Cross multiply here. I've got c times sine of 44 equals 7 times sine of 53. Divide both sides by sine of 44. And again, I'm saving all this to my last step so I can punch it in. So c is going to be about, if you punch all that in, you should get about 8 when you round on up. Okay? And again, showing you that for my last step, control division makes that fraction. 7 times sine of 53, and in the denominator I've got sine 44. 8.04, and again rounded to the 10th place, that's going to be about